And welcome back. Now today's a conclusion of a previous video where we built this Christmas tree project, which we got from, well, it was either GearBest or not eBuyer, where was it? It was GearBest or Banggood, in fact. And there was a little bit of confusion because the first kit I had, although I thought I'd ordered it with these red, green and yellow LEDs, in fact came with LEDs like this one right at the top of the tree, this one here, which is a multicoloured LED. And it goes through many colours because it's got a little chip inside it. But that wasn't going to be any good for what we wanted, because I felt I could add value to what was effectively a fairly simple kit, and it'd be ideal for a beginner, you know, a child or an adult learning to solder and put things together, because the kit itself is not difficult. And I'm not particularly promoting the kit just for the sake of having a kit. But it's a good enough kit. I mean, GearBest and Banggood sell it in both versions. And if you were to build it as is out of the box, what would happen? These LEDs would basically slowly flash on and off. But as soon as I saw this was back in March of this year, and now it's October, so it's been hanging around a while, because I thought, right, I can add value to this, or we as Arduinoites can add value to this by saying, right, a flashing LED project like this is all so well and good, but what can we do to add value? And what I was going to do is intercept, if you like, what turns the LEDs on and off. Let's have a look at the sequence of events that got me this far to actually build it, and then we'll talk about the little tiny circuit you need to make it do what it's doing now. And remember, there's two phases to this. There's one where it's noise sensitive, like it is now. It's obviously flashing according to when I speak. And then there's another phase when I stop speaking, it goes into a sort of a gentle fade up, fade down mode. So if I just stum for a few seconds. Which is all quite relaxing, really, isn't it? So now it works better, of course, with music. It's not intended specifically for a voice, it's just intended for some music. So let me cue up some music and we'll play a little tune and see what it does. Very nice. Yep, okay, let's just turn that down a little bit. Right, okay, so there we are. We're proving it works. So let's have a look at the sequence of events that took me to this stage, the building process, which is pretty simple. It's just following the instructions in the kit, really. The only difference we've done, of course, is intercepting what makes this flash. Okay, and then fade, of course, and that's all done by the Arduino. So let's have a look at that next. So the very first phase is actually to build this kit, and here you can see I've partially constructed it with a few LEDs put in. There's the second bit of it. Not a lot to it, really. A few transistors, lots of LEDs, or 27 in total, in fact. And there's the two halves, and those two sort of slot together at right angles like that. There's me just testing it out with some power. Oh yes, just showing you where I've intercepted the base connectors as well, with the wires going down, so you get two green, two red and two yellow. There's a little typical example of where I've scraped away the track and brought the wire down. It's not difficult, frankly. That's the red wire. Yeah, it's a nice little project to do, actually. I mean, get it working first as it is out the box, and then make these modifications. That's the way I'd do it, I think, to be quite honest. Now this is how it looks when you build it out of the box without making any modifications at all. The LEDs just sort of blink off on and off in sort of sequence, I guess, really. The green turns the red off, the red turns the yellow off, the yellow turns the green, or whatever sequence it is, which is quite nice in itself, but it's just a little bit passive, isn't it? It'd be nicer to be able to actually do a bit more with it, and that's where the Arduino comes into its own. So back from the workbench, I've just plugged this in very quickly to the original circuit here, the red, green, blue one. So the first thing you'll see, if I get my pointer right, the first thing you'll see, the LED down here, this big one, now is mainly showing white because it's showing the red, green and yellow all together, or blue in this case, red, green, blue all in one go. So that's nonsense. Let's not look at that at all. It's the Christmas tree at the back we're looking at. to show that the red, green and yellow lights all do flash. Not all at the same time though, they sort of overlap and do all sorts of stuff. Let me play some Christmas music. Now this is Christmas music in fact supplied by YouTube, so that's good. So it's all royalty free and stuff, so let's have a look. Works for me, sounds good. Well, not sounds good, and it's music, isn't it? But the flashing of the lights is working well. And oh, one last thing just to check. Let me stop that. Right, so if we stop that and I'm very quiet, they should start fading in and out. And they are. Hooray. Whoops. I made a noise that stopped it, but you can see I was just trying to turn it around to show you that all the bulbs and all the sides are working. Okay, I think that's a good enough demo. So what I'm going to do now, let's bring the brightness back up again to where it should be. Right, so what in fact I'm going to do now, well there's two things in fact. One is to create this audio amplifier board onto strip board or something like that. In fact, over here I've just been playing about with some layouts. So over here you'll see I've been looking at a layout or two to see how we're going to put that together, because I must admit I'd totally forgotten about that part of it. Having designed it and put on breadboard, you tend to think, well that's it then, isn't it? And of course what I'm now going to do is finish off the actual construction of this. So this is constructed okay, and I've brought the wires out. So each one of these transistor bases has been separated from where it would normally go and connected to these wires. So on each half of this Christmas tree, on each half of this Christmas tree you've got green, yellow and red. So therefore you've got two wires for each, one for each half of the Christmas tree, right? So they've been brought out, connected to something like a 4.7 kilo ohm resistor down here and to the Arduino circuit. So this is now going to be finalized so that this powers the Arduino, which is not at the moment. We've got dual power supplies. So the Arduino is being powered by this cable here, and this is being powered by this USB cable here. This actually is a USB cable. Don't want that, of course, we just want one power supply. And this is going to be mounted on this board here. Now this isn't a white board, this is in fact smoked perspex. In fact, I can show you that. If I can get this one off, it sticks like glue, doesn't it? So there we are, look, so that's transparent but smoked. You can see the smoke effect over the white board here, which looks quite nice. So what's going to happen is the Arduino and the amplifier will be mounted on here. What else needs to be mounted on there? Well, nothing really, that's it. So that's the Arduino and the amplifier board on here. This will then get mounted on top via some spaces. So where these holes are, I've got some standoffs, so it'll be, you know, maybe a centimetre off the board, something like that. And then we'll keep this power socket here, and oh, there's an on-off switch over here. That switches it all off, and I think then that'll be pretty much done, I hope. Okay, the next time you'll see this, it'll be complete, but it's working very well. So let's fade out with some Christmas music, and all thanks to YouTube, because it is their music. Alright lads, I think you're over milking it now. That's enough. Thank you. Oof. Right. See you in a bit. Right, so there it is all built, and as you can see on the oscilloscope behind me, it's picking up my voice rather nicely. And I have done some measurements on this, and we've got about 5 millivolts of noise on that, which is pretty good actually. I mean, it's good enough even for a normal audio amplifier, let alone something that's going to run a Christmas tree. So yeah, I'm happy with that, I must say. So I think we'll put this to bed and wire up the Arduino, or the Nano that I'm using anyway. Cool. Now if you are going to use a phone charger type power supply, you can see there that I've got a bit of decoupling going on the, well, this is the circuit I use for the breadboard. I'm not really expecting to use that for Arduino, but you never know. So we got the 5-volt coming in at this stage, immediately decoupling capacitor, a resistor depending on sort of the current you're expecting to flow, another capacitor which is even bigger than that one, a smaller one for the high frequency stabilization, and a nice noise-free output here. Now this simple little decoupling worked absolutely brilliantly while I was doing it on the breadboard. It made all the difference between a working circuit and a not working one, really. So a few simple things like that can really make the difference. Cool. Okay, I'm going to get the Arduino plugged into this. Right, so it's picking up my voice just fine. When I stop speaking, even though the fan's on up there, it should start fading in. There it goes. Great. Okay, so what we've got here then is that everything mounted underneath. I've mounted that one at right angles actually, so that we get to the variable resistor there. Otherwise it was going to be a real problem. We'll have to bring it out on top somewhere, which is more trouble than it's worth, quite frankly. So now I'm going to mount this on that bit of board there, and well, that should be it then, really. Just mount that in the middle like that. That should look alright. We'll see. Right, let's talk about the actual sketch, and in conjunction with the circuit diagram, really, just so that the two make sense. Couple of points then. First of all, I don't know if I've mentioned, this little tiny LED at the top here was one of those pretty little things that came with the original kit, you know, the red, green, blue ones that did their own thing, really. They didn't need any Arduino to touch them. So I put one of those at the top, and that works more effectively than you might think, because it sort of acts like a little twinkle twinkle little star at the top of the tree. So I just thought I'd give you that little hint. Now here's the circuit diagram. Now don't worry, there's a link to this, and indeed this actual PDF as well. So this is the circuit diagram, and as you can see, it's pretty straightforward and simple. How does it work when we don't change anything? Right, what happens is, look, this first transistor is waiting to be turned on, and it will turn on when the current through this resistor here, R1, fully charges this capacitor up to 0.7 volts. This then gets turned on and discharges, if you like, all these LEDs to ground effectively down here. By discharging that, it brings this capacitor down to ground as well, which then has a sort of a cascade effect from there to there to there. So they're all doing the same thing. They're all waiting for their base to go positive. And it does that very slowly as these get charged up and discharged automatically. And it's quite a gentle little operation. It's sort of, I don't know, 1 hertz maybe, something like that. So this gets charged up here, fires, everything comes on through this transistor. So the red effectively gets turned on here. By turning on, it brings this capacitor up to full power, if you like, and therefore brings this point here up to 0.7 volts, which then turns this one on, and then this one, and then this one here goes all the way back round to this one here. So this one here also then effectively discharges. Ideally these capacitors should have been non-polarized, but for this sort of kit I don't suppose you're going to get that. Not to worry. Now the other thing to worry about is this little switch. This is the power switch. When you plug it in here, what it actually does is disconnect the negative, not the positive. The positive is always from the battery and or the power socket that we plug in. Alright, so on here it's that little thing here, or the battery, which of course we're not using the battery at all for here, but I guess you could. I mean, it's just not going to last that long, is it really, if you use battery? So that switch, which is the one at the back there, switches the positive supply line, fine, but the negative is either switched to the battery or the power socket coming in. That's how it switches between the two. So when we connect up our Arduino, we need to connect the Arduino to this point here. So it's the common negative, if you like, and this point here. But that's fairly straightforward. Now, so what we do then to adapt this for use in our Arduino circuit, we simply physically disconnect the transistors at their base, so the red, yellow and green. Yes, I know that's orange, but the yellow didn't show up. Okay, and I can show you where we've physically disconnected those, and then we run a wire, so a red wire from this point just through and out, a yellow wire from here out, and a green wire from here and out. So you get 3 wires per plane of this tree. So as I said, the tree is in 2 halves and they just slot together at right angles. So here you can see, look, where I've cut the red wire, if you like, to the base anyway. So there, that's where the base was going in. It was connecting to the R1 and C3 rather. Just quickly bring the circuit diagram up so you can see it in the background. So this is what we're talking about. We're connecting a wire, that red one, to that point there, and we've cut this point here, there, and that's the C3R1 connection. So it does nothing anymore. That's why it's good to build it first and get it all working, and then you can connect these wires up later. In fact, I connected these wires up before I connected all these at right angles, so you test each half in one go. So we do that all the way around. We just do it for the 3 transistors on each plane. So that was the red. The yellow is, whoops, is that over here, connected in, and underneath there I think it's been disconnected. Bit difficult to see now. I've connected it out. You can just make it out. And the green must be somewhere around here. Here we are, look. There's the green. I've marked them on there actually, which colours are which, just so I could test them and make sure I've got the right colour wires coming down. And these wires then that do come down are sort of in the Christmas tree sort of theme, aren't they? So they don't look particularly out of place. Okay, that's the simple circuit amendment you have to do then. Okay, and one final point on this, these resistor values that refer to this kit aren't totally accurate. We don't always use the 1K, and the capacitors I think are slightly different. But just go with what's in the kit. It all works quite wonderfully well. But this was the link to the circuit diagram given on, I think it was the Banggood site. Doesn't matter. It works anyway. So let's have a look at the sketch and we'll see how we actually control these lights. As you can see here, it's called PWM. Now we are fading these lights. When I stop speaking and the sound and light thing doesn't do anything anymore, then we are fading them in. And we fade them in, of course, in pulse width modulation, which, just to make sure you understand that, we issue a very high frequency pulse. It's probably at about 490 Hertz actually for one or more pulses, which the Arduino's got built in on some channels, not all of them though. You have to look at the squiggles on the circuit board. Anyway, we're using 9, 10, 11. There are our 3 channels. We're using an analog microphone input. Here we're just saying that the minimum time that any one of these LEDs can be on for is 50 milliseconds. You might not want that. You might say, well, 25 is enough for me just to make it flash a bit quicker or to react to sound a bit quicker. That's entirely up to you. You can play about with that. Setup does nothing apart from set up the debug window. I'm going to skip right down to the bottom actually and say this one here. So this is how we detect sound. Now the sound of course comes in on the board here via the amplifier. Here it is, which you've seen plenty of times now, both on the circuit board and the breadboard rather, and on here. So the output of this goes to A0. Now funnily enough, the volume control that I was so worried about, which is why I mounted this at right angles, I've not had to touch since it's been on. It just the automatic gain feature, if you like, just works so much once you've got it. And of course the code works in a slightly different way to what you might expect. However, sitting it at right angles has a good effect because the microphone can then be pointed straight out. You do have access to this then to experiment a little bit. And, well, frankly, people are fascinated by seeing exposed electronics like that. So I think, yeah, it's a good little talking point. So anyway, what are we doing then? We're reading in on the microphone value. I call it microphone, it's the amplified microphone. I'm reading in on the microphone analog input the value at any one instance, right, as this is called. it says, right, go and read the microphone value 1. Then we have a 2 millisecond delay, and then we read that same one again, but take away the value we first had. Now why? I think I've described this in a previous video actually, but let me just recap very quickly here. Right, time for a quick diagram to see how we're connecting the Arduino up on A0. So A0, which is the microphone input. So if you can imagine on our input to the microphone, what we're seeing is a voltage level that does that sort of thing. And what we're saying is we're taking a snapshot at any one instance. So if we took a snapshot, say there, as our first snapshot, and then we took 2 milliseconds later, another snapshot there, we can see that the voltage is increasing. If on the other hand we were to take a snapshot there as our third one, and then another one there, we can see that the sound is actually less prominent now. So the sound intensity is going down. So there's no sound at all. Here there's sound, and that's all that routine does. It goes, is there a sound increasing intensity at the instant that I request it? That's it. That's all there is to it. So back to the code window. Okay, so this is so there's a serial print here as well, which I'm going to have to remove because that's taking quite a bit of time up actually. So here's the main loop, and what are we saying is happening in the main loop? Now there are various counters and arrays, if you like. That's what these little brackets mean here. They mean this is an array. Fade value consists of an array. Now here we've got 3 values, -100, 0 and 255. That's why it's signed. And it's always a good idea to put in signed or unsigned depending on what you really mean, because you can get caught out otherwise. If you don't put anything in, it will be signed, but it might not be what you want. But here I do want it. This is the silence level. As it's taking a value from the timer, we probably will get big values eventually. The mode we're running in, and we start off in flash mode, so as you can see here now it's flashing, and that's the mode it will start off initially. If the silence period is exceeded, it goes, right, there's been silence for the period you've told me, I'm now going to stop flashing or trying to flash or waiting for a sound and go into the fade up, fade down mode. So it's saying if we are in flash mode, let's have a loop here that says for my array of PMW, we've only got 3 colours, it's RGB, so it's 3 really, right? We're going, have I got an input? So it starts off with the first one, which says red in this case, right? Have I got an input? If I have got an input, go and flash that channel. Okay, and count. A true means I want to flash on, not off. Okay, and then we say let's keep track of when we found the last sound. Now if we don't find a noise on the input channel, it says, well, now's the time to turn that channel off. Then we say if we've had silence for long enough, and here I've got it down to 1,000 milliseconds, 1 second, what we're saying is, right, forget the flash mode, there's been silence for too long, we're going to start going into fade mode, and the serial monitor says that. And then we come out of this loop because there's no point in continuing with it. If we haven't had a sound, we come out. Now if we're not in flash mode, if we're not in flash mode, which means we're in fade mode, we go around the same loop, but this time we say, hang on, have we got a sound now? If we have, then we've got to come out of fade mode and go straight back into flash mode. So I'll exit this little bit of the loop and go straight back out to the top of the bit we just saw. It doesn't do it immediately. It says we're in fade mode. That is, I haven't detected any sound for a second. And remember, where I've got that hard-coded value, that's poor programming. I'll admit it, hands up. That's a magic number, isn't it? What does that mean, 1,000? That should really be a declared at the top. If I've got a sound, I've detected a sound now, but I'm in fade mode, I'll add 1 to my sound count. Now, if the sound count is more than 1, that is to say I've had a sound and then I've had another sound as well the second time I've tried this, that means, right, there is now sound coming along. I'm exiting the fade mode. So it doesn't exit immediately, and I've tried playing about with this value as well, this 1, and it it varies in intensity between 1 and 2 and 3. I found 1 actually, greater than 1. So you've had sound twice on the trot within 2 milliseconds. That's enough to switch it back into flash mode. Which means when this goes into fade mode, pretty much instantly, as soon as there's a sound, it comes back into flash mode. Right, that's all the loop does really. You're either in flash mode or you're in fade mode, and they both check to make sure they should be in that mode, flash or fade, and if not, switch to the other mode. Pretty simple really. So what does the fade channel do? Okay, fade channel says, right, which channel do I want? So it's red, green or yellow channel. Here I'm saying I'm fading at different values between channels. All right, so the red will fade at 15 milliseconds, red, green will be 10, and yellow will be 20. And here's my fade time, that is to say, how long have I been fading for already? Well, of course, when you come in the first time, it won't be 0. So we're not faded for any time yet. But this loop here basically says, I've started fading. So let's just take one channel at a time, red. I'm adding one to this first count. I go, right, I've started my fade loop. I'm incrementing this count. It's adding the time in. It's going through this loop a few times. And it keeps incrementing that time until we get to the 255 mark. Now 255 is the maximum you can have on a PWM pin. Basically it means fully on. And if we get to that point, we flip it and go, well, you're not at plus 255, now you're at minus 255, which has no effect on the actual analog pin, but it does have an effect on our counter. And we can use this little construct here to then fade back down without having complicated sort of logic. So it just flips the bit effectively and goes, oh, I'm at minus 255. Well, I better start decreasing my fade rate to get down to 0. And here's where we actually write out that value and update the pointer. Now, you probably missed it as we came in, but this one here, this signed integer of fade value, it's got a star on it. That's a pointer, which means we can update that value. And when it's called from the loop, this value is actually updated and is available to the calling program. That's in there purely to show you how to use a pointer in a very, very simple sort of way. It's a good little trick to use, because otherwise the value that you have here would have to be kept only internally, or you'd have to use a global variable. Well, we don't have to use a global variable now. This variable that we're passing in is a pointer to a variable that is declared in our main loop. So if we go back to the main loop, which is here, we're saying fade channel. Here we're saying fade val count, count being the channel. The ampersand there says this is a link, a pointer to a value here. I'm giving you the address, not the value, I'm giving you an address of a variable. So when it comes down here, it knows that this is not an actual value itself, it's the address of a value. Yeah, I know. I'm just putting it in there so you can see how it works. If you don't like it, if you think this is an added complexity you don't like, fine, take off the star there, take off the ampersand up here, and just make fade val a global variable that is declared before the main loop, before setup, and it'll work the same way. Just that global values are messy. They're always around. They can get corrupted by the things that you didn't intend to. Okay, so that's the fade, and the flash is sort of even simpler really. So what we've asked for, we've said for a particular channel, so let's take red, which is channel 1 for example, I want to either flash on or off, turn on or turn off basically. Here are my 3 channels, but we're interested in the first one. So if it's flash on, we say turn it fully on to 255. And if it's not flash on, that is we want to turn it off, we first of all say, you've asked me to turn off the red channel, but I haven't been on long enough. I haven't been on for the minimum amount of time. That is to say 50 milliseconds. All right. And it works it out by looking at how long this channel has been on for, and it's the flash on milliseconds, which is declared right at the top as 50 milliseconds, times the channel number. So that means channel 1, which is 0, 0 times that means I can switch off straight away. But if it's channel 1, green, green times that would mean I've got to be on 50 milliseconds, and yellow has got to be on even longer, which is why you'll see these being turned on and off at different rates, because they've got to stay on for longer. So if they've got to stay on for longer before another channel can be switched on, that gives you that sort of multi-channel effect. Okay, trust me on that one. And that's it. Now we're down to the microphone input again. To fully understand this sketch, it's probably worth downloading it and just having a look and seeing which bits of it are confusing or not clear. Obviously I've played around with a few values to see what's best and some tricks of the trade, if you like, to fade up and fade down, but it's not that complicated. And if you really don't care about the code, and I don't blame you one bit for that, really, I don't, you could just use this code as is and maybe change the 1000 milliseconds here for the silence, and you can change the 50 milliseconds minimum on time, and you get sort of a slightly different effect, really. I think that probably covers it. If I go into any more detail, this whole video would be an hour long, and this isn't a course in advanced C++ programming, is it? Not that it's advanced. No, believe me, it's not. This is fairly straightforward C++. Okay, I'm going to leave the coding there because I think that probably covers it. And as I say, if you download that code, you know it's going to work on this kit with that circuit adjustment that we've done there. And you could build it, and then perhaps when it's working, you can then play with the code and change it and just see what effect it has when you change things on. Oh, as it happens, though, we just had to be stopped at this point here. I don't turn the channels off, even if when it says on the flash here, it says, look, flash, do I want to turn it on or off? Well, we want to turn it off, and yes, we've been on for the minimum amount of time, so I want to turn it off now. But if you look, I actually turn it down to a level of 2, not 0. Because 2 is just that tiniest glimmer that you can just about see, so that any one of these that is off actually has the minimum glimmer on it. Now you probably, I keep disconnected, don't I? You probably can't see that in the daylight. Or perhaps you can actually. Just watch that yellow one, for example. You see? And the red one, look, is that a little glimmer? See, it doesn't go fully off. Look at the difference when I unplug it, for example, to when you see the glimmer when I stop speaking. Now that's off, right? There's absolutely no glimmer on there at all. But when I plug it back in again, see? That little tiny glimmer. And that's pulse width modulation level, or value, 2. I tried a 1. 1 was actually tiny, a bit too little. But you could put a 3 or a 4 and just see if that suits your needs better. So you can just have that LED on that little fraction, which stops it going fully off. And that's it. There we are. There's just not that much to it. So there we are. We're going to stop there because otherwise the video gets too long. Okay. That is the Christmas Tree project. Now, as I say, I'm not specifically promoting this kit from either Banggood or GearBest. It just happens to be a nice little thing. But I say the Maplin one that we discussed a few videos ago now, which is basically just one of these pieces of thing with far fewer LEDs, could also be amended in a similar way. But I just think this 3D one just looks better. Now, you're not getting the full effect of this because the video camera will insist that it's going to light up my desk no matter what. So it always looks like daylight. And the LEDs themselves always look white in the middle, don't they, on the camera rather than the colour? One of those things about videoing, I guess, or cameras. So you're not getting the full effect. But when this is in a, I don't know, should we say, a semi-darkened room, like you might have in a room, a lounge, at during November or December, it really does look a treat. And it's fascinating that when you speak or the television's on, these all flash in time, and when there's a pause, they just fade in and out very nicely. And of course that little twinkle little star at the top just gives it that little added je ne sais quoi. Okay, right, we're going to leave it there I think it's a nice little project. I hope you think so too. Oh, I hope you like the smoked perspex that it's on. That's pretty cheap. You can get this from eBay actually. Nice little stuff. I got it cut to size like that. I think I've got 4 bits out of an A4 sheet. They cut it for me. I mean, I've got these little standoffs. These are plastic standoffs. Now I bought a kit of these from either Banggood or GearBest. They come in a little plastic box and they're all various heights, from tiny little ones to tall ones. I used some in a different project. Which project was that? It could have been my coffee cup coaster actually. Anyway, it was about 3 or 4 quid. I thought I'll try it, and believe me, these are great, and I like them because they're plastic, so there's no worrying about shorting stuff out. You just stick them in willy-nilly, and the bolts at the bottom are quite narrow. Look, if you look at the depth of that. So these little stick-on feet I got from eBay yonks ago. I've had these for a long time, and they just keep it all off the circuit, off the table, and stop it moving about. Right, we've run out of time, well and truly this time, so thanks very much for watching. Do remember to spread the word, give me a thumbs up if you think the video is interesting, and see you in the next video. I hope you're finding these videos useful and interesting. Please leave comments down below, subscribe, share, and give me a thumbs up. Thanks for watching. See you in the next video.